You call your doctor's office and an AI answers. It understands your question, checks the calendar, and books your appointment, all in a natural conversation. No menus, no hold music, just a voice that sounds completely human. How does this actually work, and how hard is it to build one yourself? Let's break it down. Welcome to Tech Decoded by AmtocSoft. I'm Alex. Voice AI is one of the fastest-moving areas in technology right now. Customer support bots, real-time translation earbuds, AI podcast hosts, they're all built on the same fundamental architecture. In this video, we'll cover everything you need to know. First, the three core components that make up every voice AI system. Then, the critical latency budget that makes or breaks the user experience. We'll compare the major tools and frameworks available in 2026. I'll show you how to build a basic voice agent in Python. And finally, we'll talk about what it takes to run voice AI in production. Whether you're a developer looking to build with voice AI or just curious about how it works, this is your complete guide. Let's start with the fundamentals. Every voice AI system is built on three core technologies. Think of them as a relay race where each runner handles one leg. First, speech-to-text, or SDT. This is the listening component. It takes raw audio from a microphone and converts it into written text. When you talk to Siri or Alexa, the very first thing that happens is your voice gets transcribed into words. The state of the art in 2026 is remarkable. Models like OpenAI's Whisper achieve under 5% word error rate on clean English audio, meaning they get 95+ words right out of every 100. And they work across 99 languages. Second, text-to-speech, or TTS. This does the reverse. It takes written text and produces natural-sounding audio. The evolution here has been dramatic. 5 years ago, AI voices sounded robotic and choppy. Today, models like 11 Labs and OpenAI TTS produce voices that are nearly indistinguishable from real humans, with emotional expressiveness, natural pauses, and consistent character. Third, the brain in the middle, a large language model, or LLM. This is where the actual thinking happens. The LLM receives the transcribed text, understands the user's intent, reasons about a response, and generates the reply text. This could be GPT-4, Claude, Gemini, or an open-source model like Llama running locally. A voice agent chains all three together. SDT captures what you say, the LLM thinks about it, and TTS speaks the response. The whole loop needs to happen fast enough that it feels like a real conversation. And that brings us to the single most important number in voice AI, 500 milliseconds. Research in conversational dynamics consistently shows that humans expect responses within about half a second in natural conversation. Go beyond that, and the interaction starts to feel awkward. Past 1 second, it feels broken. Past 2 seconds, people hang up. Here's what eats into that budget. Audio capture and network transit take about 50 to 100 milliseconds. SDT processing takes 100 to 300 milliseconds. LLM inference takes 200 to 800 milliseconds, depending on the model. TTS generation takes another 100 to 300 milliseconds, and audio delivery back to the user takes 50 to 100 more. Add it all up, and you're looking at 500 to 1600 milliseconds total. That's too slow for natural conversation. So how do the best systems get under 500? The answer is streaming and pipelining. Instead of waiting for each stage to finish before starting the next, you overlap them. The SDT starts processing audio before you even finish speaking. The LLM begins generating its response token by token, streaming partial results. And the TTS starts synthesizing audio from the first sentence while the LLM is still generating the rest. With this approach, the first word of the response can start playing in as little as 280 milliseconds. That feels instantaneous. Let's talk about choosing a TTS engine, because this is where most of your per-minute cost goes. There are 4 main options in 2026. 11 Labs is the quality leader. Their voices are the most natural and expressive. They support voice cloning from just 15 seconds of audio, but they're expensive, about 30 cents per minute. OpenAI TTS is the sweet spot for most production use cases. Great quality, simple API, and 20 times cheaper than 11 Labs at about 1.5 cents per minute. Kokoro is the open-source disruptor. It runs locally on your machine, costs absolutely nothing, and sounds surprisingly good. All of the AmtocSoft YouTube narration you're hearing right now is generated by Kokoro. 0 API calls, 0 cost, and Piper is designed for edge and embedded devices. It's extremely fast with minimal resource usage. Perfect for Raspberry Pi and IoT applications. My recommendation? Start with Kokoro for development and prototyping. It costs nothing and lets you iterate fast. When you need production reliability and the best possible quality, upgrade to OpenAI TTS. Only go to 11 Labs if voice quality is your primary differentiator and you have the budget for it. For speech-to-text, the landscape is simpler. OpenAI's Whisper is the open-source baseline. It's free, supports 99 languages, and achieves best-in-class accuracy for batch transcription. The catch? It's not optimized for real-time streaming out of the box. DeepGram Nova is the fastest option for real-time applications. It achieves sub-250 millisecond latency with streaming, making it ideal for voice agents where every millisecond counts. It costs about 0.5 cents per minute. Google's Speech API with Chirp offers the widest language support and solid accuracy, but at a higher price point. The decision framework is straightforward. If you're transcribing recordings or podcasts after the fact, use Whisper. It's free and the most accurate. If you're building a real-time voice agent, DeepGram gives you the lowest latency. And if you need broad multilingual support, Google is your best bet. Now let's build one. PipeCat is an open-source Python framework that makes building voice agents straightforward. It handles all the plumbing, audio capture, streaming, turn-taking, interruptions so you can focus on the AI logic. Install it with pip install PipeCat AI. Then you set up a pipeline. The pipeline connects 4 components in sequence. First, an audio input that captures from your microphone. Second, an SDT processor. You can use Whisper, DeepGram, or any supported provider. Third, an LLM processor, GPT-4, Claude, Llama, whatever you want. And fourth, a TTS processor, 11 Labs, OpenAI TTS, or Kokoro. PipeCat handles the hard parts automatically. Voice activity detection determines when you've stopped speaking. Turn-taking logic knows when it's the AI's turn to respond. Interruption handling lets you cut the AI off mid-sentence, just like a real conversation. And streaming ensures responses start playing as soon as the first tokens are generated. The entire setup is about 50 lines of Python. You define your pipeline, configure each component with your API keys, and run it. In about 20 minutes, you have a working voice assistant that you can talk to naturally. What makes PipeCat special is its modularity. Want to swap from OpenAI to Claude? Change one line. Want to switch from DeepGram to Whisper? Change one line. The pipeline architecture means every component is independent and interchangeable. There are 2 fundamentally different approaches to building voice AI, and choosing wrong means a costly rewrite later. The cascading pipeline approach chains 3 independent components, SDT, LLM, and TTS, in sequence. This is what PipeCat and most frameworks use. The advantage is flexibility. You can swap any component without touching the others. You can use best of breed for each stage. And debugging is easier because you can isolate issues to a specific component. The downside is latency. Even with streaming, you're looking at 450 to 750 milliseconds total. The end-to-end approach uses a single model that processes audio input and produces audio output directly. GPT-4o's voice mode is the best-known example. The advantage is speed, 200 to 300 millisecond total latency, and the ability to preserve tone, emotion, and nonverbal cues. The downside is vendor lock-in and less customization. The best production systems in 2026 use a hybrid approach. Simple queries like greetings and confirmations go through a fast end-to-end model for sub-200 millisecond responses. Complex queries that need reasoning get routed to a full cascading pipeline. A lightweight router makes this decision in under 50 milliseconds based on query complexity. This gives you the best of both worlds. Let's talk about what happens when you try to scale a voice agent to real users. This is where the economics get interesting and sometimes terrifying. At 10,000 calls per day, averaging 3 minutes each, here's what TTS alone costs. With 11 labs at 30 cents per minute, you're looking at $9,000 per day. That's $270,000 per month. With OpenAI TTS, it drops to about $900 per day. Still $27,000 per month. Self-hosting Kokoro on a single A10 GPU handles the same load for about $50 a day. $1,500 per month. That's 180 times cheaper than 11 labs. The trade-off is operational complexity. Self-hosting means you own the infrastructure, the monitoring, the model updates, and the failover. For a team of 2 to 3 engineers, the total cost including salaries still favors self-hosting above about 5,000 calls per day. The 3 metrics that matter in production are time to first byte, keep it under 500 milliseconds or users hang up. Word error rate, keep it under 5% or users get frustrated. And conversation drop-off rate, keep it under 10% or your UX is fundamentally broken. Voice AI isn't a future technology, it's deployed at scale today. Customer support is the biggest application. Companies use voice agents to handle routine calls, appointment scheduling, order status, account inquiries. The best implementations handle 60 to 80% of calls without human transfer. Healthcare is seeing massive adoption. AI scribes listen to doctor-patient conversations and automatically generate clinical notes, saving clinicians 1 to 2 hours of documentation time every day. Real-time translation devices let you speak in English, and the person across the table hears your words in Japanese within a second. The pipeline is SDT, machine translation, then TTS. Content creation is booming. AI voices narrate audiobooks, generate podcast episodes, and dub video content into multiple languages. And voice commerce is growing rapidly. Shopping by voice with a conversational AI assistant that helps you browse, compare, and purchase, all through natural dialogue. Let's recap the key takeaways. Voice AI has 3 pillars: SDT for listening, LLM for thinking, TTS for speaking. The 500 millisecond latency threshold is what separates natural from robotic. For TTS, start with Kokoro, upgrade to OpenAI or 11 Labs for production. For SDT, Whisper for batch, DeepGram for real-time. Pipecat makes building a voice agent straightforward in 50 lines of Python. At scale, self-hosted voice AI can be 100 times cheaper than API-based. And the hybrid architecture, end-to-end for simple, cascading for complex, is the winning pattern in 2026. If you found this helpful, hit subscribe and the notification bell. We post AI tutorials every week from beginner to professional. Check the description for links to the full written guide, the Pipecat tutorial, and our TTS comparison blog post. If you want to support the channel, there's a Buy Me a Coffee link in the description at buymecoffee.com/AmtocSoft. Next video, we're diving into AI security, prompt injection attacks, and how to defend against them. See you there.